Assalamualaikum warahmatullahi wabarakatuh. My name is Nu'atira binti Muhammad Syahabuddin from Bachelor of Electrical Engineering Year 3. I am a representative of the G1C7 group. I'm going to explain the solution for example 4.6 Final Exam 2018-2019. As servicing engineer at XXX factory, you are assigned to evaluate the performance of synchronous motor at the factory. The specification of the motor are 380 volt, 100 kV ampere, 0.8 PF leading for the power factor, 300 Hz frequency, 4 pole Y-connected synchronous motor, synchronous reactance of 0.75 per unit, and its armature resistance is being neglected. For the first question is, by assuming this motor operating at rated condition, all losses is being neglected. Determine the output torque and rated armature current, which is IA. First, we are going to search for the speed rotation of this motor. We will be using this formula, N synchronous equal to 120 times with frequency divided by number of pole. We will get 9000 R over min. Since all losses is being neglected, P in rated equal to P out rated equal to S rated times with power factor. Then we will get 80 kilowatt. The output torque of this motor is, we are going to use this formula. Torque induced equal to P conversion divided by omega m. For the since RA equal to 0, no electrical losses. So P conversion equal to P out equal to P. The answer is 85 Nm. Next, we're going to search the value for V phase. We're going to use this formula Vt over Z3. Then we will get 219.39 volt. Then the rated armature current of this motor is IA equal to IL equal to P over Z3 Vt PF. The answer we will get is 152 ampere. For the power factor is leading, so it is positive. The final answer for the IA is 152 and the degree is 36.87 degree ampere. Next, for the question B, estimate the internal generated voltage of this motor based on the question 4A. The base impedance of this motor is Z base equal to 3 V phase base square over S base. The answer for the Z base is 1.44 ohm. SXS is the synchronous reactance, which is the value given in the question. It is 0.75 per unit. For the SS, we will search for the actual reactance, so we will convert to ohm, and we get 1.08 ohm. Lastly, we will search for the internal generated voltage. We will use this equation, EA equal to V phase minus JXS IA minus RA IA. For the RA is equal to 0, and J we will use 90 degree. The final answer is 343.95 negative 22.45 degree. Next is question C. Based on question 4B, if the field current IF remaining at the value present in the motor, evaluate the maximum possible output from the machine. We will use Pmax equal to 3 V phase times EA divided by XS. The answer we will get is 209 kilowatt. The speed of shaft does not affect. The larger field and magnitude of internal voltage contribute to the higher power. Next, the fourth question is, It is possible to increase the power output. Justify your reason. Yes, it is possible. Power output is possible to be increased by increasing the shaft of motor. In this situation, the rotor will initially slow down because of shaft increase. The internal generated voltage, EA, will be out to larger angle while the magnitude is constant. The armature current, IA, and input power will increase eventually, increase the output power, P, as the power factor also increase. Next, question E. If the motor initially supplying 100 horsepower at 0.8 lagging, estimate the maximum induced torque if all the losses is being ignored. First, we will convert the horsepower to watt. P in equal to P out equal to 100 horsepower times with 746 watt divide horsepower. Then we will get 74.6 kilowatt for the power output. Next, we will calculate IA equal to IL equal to P per sub3 VT times with power factor. Then the answer we will get is 141.68 ampere. Next, we will calculate power factor. The power factor we will get is negative 36.87 degree. The power factor is lagging, so it is negative. The answer we will get for IA is 141.68 negative 36.87 degree ampere. Then we will search for EA. We will be using this equation, which is EA equal to V phase minus J XS IA minus RA IA. The J we will use 90 degree. The answer for EA is 176.81 negative 43.82 degree. Question is, discuss the best method to start this synchronous motor if it is connected to a power system. Give your reason. At present, damper windings are most widely used method of starting a synchronous motor. A damper winding is made up of heavy copper bars inserted in slots cut into the pole faces of the rotor. The copper bars are then short-circuited by end rings at both ends of the rotor.